In this video, we're going to talk about graphing data. Now, I know the title of this section says collecting and graphing data, but our textbook doesn't really talk about how to collect data. So what we'll just do is talk about really the two types of data you're going to see. The first is categorical data. So categorical data is data that you categorize like your eye color. People, if you look and ask everybody their eye color, that would be considered categorical data. Um, let's see, ethnicity. Ethnicity would work for categorical data. Another example would be zip code. Now, zip codes are giving what we call a numerical answer, but it's not a numerical data. It's technically categorical data because it's giving a location. The other type of data is numerical data. So this is actually measured data. That's the difference between having the data be like actually a number, like a zip code, but something that is actually measured or could be counted, which technically counts as a measure. Okay, so height, age, number of pets, those would all qualify as numerical data. So visually, we have a few different options when we're graphing data. So let's start with categorical data and then we'll move into numerical data. There's really not a lot for categorical data and there's a whole bunch of numerical data. So let's start with categorical data. So categorical. The first type we'll have is bar graphs. And most people know bar graphs uses rectangles. To represent each category, the amount in each category. Okay, so let's do an example. So let's say we have a movie review website. Wow, that's not how you spell review. Movie review website, which lists movies for the last year. And I'll just kind of summarize that for this website. There were 8 5-star films, 24-star films, 12 3-star films, 8 2-star films. Oops. Oh, I'm sorry. I bumped that button. 8 2-star films. And then last would be 4 1-star films. All right, so there we go. Now, even though they have a star system, which appears to be numerical, they aren't really numerical. It's a category. When you say something is a 5-star film, you're saying it's excellent. It's one of the best films you've seen. 4-star would be a next step down, and so forth. Okay. So there we go. Let's say we want to do a bar graph of this information. So here's what I would do first. I want to create 2 axes, horizontal and vertical axes. Oops. On the horizontal axis, that will be where I'll label the films. And then on the vertical axis, that's going to be what I'll label the amount for each film. Wow. Sorry. It's just a really badly drawn vertical axis. Let's fix it up. A little better there. Okay. We call these numbers, by the way, the total in each category. There is a vocabulary word, frequency. The frequency for each category, the amount in each category. Okay, so just so you know, we call that frequency. So let's see, for the horizontal axis, we will do, I guess we could go from 1 star to 5 star. That kind of maybe makes sense. So 1 star, 2 star, 3 star. Those are supposed to be little stars. Not doing a good job. 4 star and then 5 star. And then on the vertical axis, since 20 is the largest number, I think I'll go by twos. Actually, fours would make sense for this one, right? Every number is divisible by 4. 4 would make sense. So let's do go by 4. So 4, 8, 12, 16, 20. Okay, now, big thing, take a sec, maybe make a note. You definitely need to label your axes, okay? So even though it's clear we're calling these stars, these would be number of stars. This would be number of films, or you could put frequency. Both would be acceptable. All right. And then we're going to go ahead and do bars for each category. Now, big distinction between bar graph and histogram, which we'll see later on, is that with a bar graph, the rectangles do not touch. Okay. So for the 1-star films, here, use my red pen. We are at 4. 2-star films get up to 8. 3-star will be 12. 4 stars, 20. And then 5-star will be 8 again. All right. Try to make the rectangles same size. Definitely didn't get them same spacing. It would have been nice if the tick marks were at the center of each rectangle. All right, but it's okay. When you're hand drawing, it's not going to be perfect. You do the best you can. And that's okay. I recognize that our graphs won't be perfect, but what I will be looking for are titles. And then the other major thing I really like to look at is that when you're choosing tick marks, I don't like just a couple. I want, typically, if I can go with 5 tick marks, I will. Okay. 5 or more is better. So like I wouldn't have gone by tens on here because then I would have only had 2 tick marks. I'd have a tick mark at 10, tick mark at 20. And that to me is just not even enough. All right. So I typically like to have more tick marks, especially on the vertical axis. Obviously, the horizontal axis is kind of dependent on how many categories we have. Okay. But definitely do that. And then the titles for each. That's what I want to see. Okay. So there's bar graphs. Now, I do want to make a note that it is possible to have double bar graphs or even triple bar graphs. And what's nice about double bar graphs or triple bar graphs is it allows us to compare categories much on the graph itself. So there is like a really nice example of a triple bar graph. Here, I'll give an example for this one on page 407 in your textbook, figure 7.3. And if you do want to take a second, pause the video, go look at it really quick, that's fine. Just so you could kind of get your eyes on it. What's really cool is it's actually a pretty nifty triple bar graph. It compares the percent of the households in the US based on how many people are in the household, starting back at 1790 up to 2010. And it's neat. You kind of see the bar graph switch from the 5 or more houses being the dominant one to in 2010 1 to 2 people being the dominant household size in the US. I just think it's kind of nifty. But it's, as you can kind of see when you look at that, it gives you a good way of comparing those years. Okay. The next type of graph we're going to look at are pie graphs or pie charts, however you want to say that, but I think our book calls them pie graphs. So this is obviously where we use a circle. And it's wedges, call it wedges, to represent percents. Wow, to represent percents of each category. So again, we're still talking about categorical data. Okay, so here, let me give another example. Let's say we had teachers respond. Teachers' response. So here, teachers' response to changing the school start time. So they did a survey of the teachers to changing school start time. And I'm not going to give any more information. That doesn't really matter for us. And here were the results. 18 were in favor. 14 opposed. And then 8 had no opinion. All right. Then I want to do a pie graph. Okay, now first and foremost, pie graphs are kind of difficult by hand, okay? But they're a really good practice when you are doing geometry, kind of learning about circles. It's kind of a good practice for that. So I'm going to attempt to draw a circle, and maybe you'll be more precise than I'm going to be, but I'm going to do my best to draw a circle. All right, best I can do right now. Okay, now the wedges, of course, depend on the percents for each category, which we are not given, so we need to calculate that. All right, so let's just take a second and do that. So for those in favor of changing the start time, that would be, let's see, 18 plus 14 is 32 plus 8 is 40. Okay, so we're taking each of these out of 40. So 18 out of 40 is, I taught times them. 18 divided by 40, there we go, is 45% or 0.45. Okay, so 45%. Great. I'm going to give myself a little space because I'm going to put some more work here. So oppose 14 out of 40. Let's do that. I'm getting 35% or 0.35. And then no opinion here. I'm just going to put NO for no opinion. Those will be 8 out of 40, which is going to be 20%. All right. So there's the percentages, but that's not really enough. They take it a step further because we understand how circles work. And the way a circle works is we have a center, which I'll put about there, okay? And also every circle has the radius going from the center out to the circle, okay, that line. But if we were to measure the angle of every circle, it's 360 degrees, okay? So they are actually going to take the time to figure out how many degrees each of these categories would take up for the circle, okay? So for those in favor, you would take the 18 over 40 or the 0.45 and times it by 360, okay? So times 360. And that comes out to 162 or 162 degrees. Okay, real quick. So from line to line, that's considered 180 degrees. Okay, a full straight line is 180 degrees. So this is just a little bit less than 180 degrees. Okay, kind of keeping that in mind for drawing. I don't have as much space here, so I'll do 0.35 times 360 because I want you to know they're both the same. Times 360, 126, 126 degrees. So that since this is 360, A third of it is 120 degrees. So this is about a third, which makes sense, right? 35%, very close to 33%. And then down here, I'll go back to fraction, 840 times 360 degrees. That's going to be 72. All right. Okay, and 72, let's see. This represents what's called 90 degrees, and we're going to talk more about geometry in the next class. So if this is kind of rusty for you, don't stress. I'm not going to test you on any of that. And also, there are ways of measuring angles using a protractor. So that comes also in the future, but they do actually make a point of bringing it up now. Okay, so let's see, 162. I said it's going to be a little bit less than 180. So here, I'll approximate it right about there. Okay. And here, I'll put it in green. So this is 162. Okay, so for a third, I'm going to say maybe about there. Call that a third. So that's about 126 degrees. Oops, I wanted to do that in green. Silly Allison. Try that again. All right, and that leaves this last little bit to be the 72. Okay, it's also smart then to go ahead and label each category. So this is those who were in favor represent 45%. Those who were opposed represent 35%. And those who have no opinion, which I will squeeze in, is 20%. And there's the pie graph. Okay, so I do, because there's so many numerical graphs, I'm going to go ahead and I'll put a couple of them here because they kind of build on the bar graph scenario. All right, so we're going to move into numerical data. And the first type is what we're going to call a pictograph. So a pictograph kind of mimics the bar graph a little bit. Oops, sorry. So like a bar graph, in fact, I'm going to write this phrase like for the next 3 graphs. It's like a bar graph, but it uses pictures to represent a certain numerical amount. All right. So let's for the sake of kind of showing this, and and honestly, a pictograph is best done on a computer, not by hand, okay? But I'm going to try to give myself an easy picture. So I actually want to revisit the movie review. So movie review revisited. So in that we had the categories we had listed above, the 5-star, the 4-star, the 3-star, the 2-star. Okay. Since you have that on your paper, I'm not going to rewrite it, but you are welcome to go ahead and rewrite it down. So here's how we would kind of display that. First, we need to create our picture that we're going to use and the numerical value of it. So for us, I'm going to go ahead and use a star. And the star is going to represent 4 movies. All right. Then I'm going to go ahead and give myself a horizontal axis. Now, it is kind of a little bit optional if you're going to do a vertical axis. It's not really necessary. It's more just to kind of say maybe what the visual represents in the picture itself, so you don't have to do like a special little label like I did. So like in the book, for the vertical axis, they would actually say star represents 4 movies, or something like that. Okay. Excuse me. Then they have the categories. So we had the 1 star, the 2 star, 3 star, 4 star, and 5 star. And here I'll label this axis as number of stars for movie rating. And then I'll go ahead and label. So the 1 star movies, there was only 4 movies in that category. For the 2 star movies, there were 8. 3 star movies, there were 12. 4 star movies had 20. So I'll need to do 5 of these. And then 5 star movies had 8. Now you can be clever and maybe say, okay, instead of using a star, because I'm using that word a couple times in this problem, maybe I could do a film reel, right? That's supposed to be a film reel, right? Or something like that. And I'm like, each film reel represents 4 movies. Okay. That's could be the idea. Okay. But it's a cuter way of representing a bar graph. What's kind of nice is it also talks about weight in each category. It still represents how much is in each category, and it helps with counting skills as well too, for that, and maybe even creating weight to each category is also kind of a great system for learning. Okay, so those are pictograms. Then there is something a little bit more basic from pictograms. Same basic idea, the line plot, but instead of actually using a picture, it uses an X. Uses, all right, sorry. Let me start with my first statement. Like a bar graph, but uses an X to represent one individual in each category. I use that word individual loosely. We tend to, when we hear the word individual, we think a person, but it could be like we're talking about counting hats, right? Could be inanimate objects. All right. So I'm using that word individual loosely. It's counting for one of whatever object or person that we are looking at. Okay, so here, let me go ahead, and this time I'm actually going to give you the graph. Students are asked how many pets? How many pets they own? All right. So the line plot typically starts with another number line. They could, again, possibly do a vertical axis. The vertical axis just kind of helps for counting a little bit, especially if you like the one in the book uses almost like a grid structure for it for ease of creating the X's. Typically, when I do a line plot like by hand, I typically don't include the vertical axis. Okay, so here, let me go ahead and give you what the picture is going to look like. So we have 0, 1, 2, 3, 4, and 5. That was the data in this one. And then we had okay, and here I'll label above what's in each category. So for the first category, there are 4 of them. Second category, there's 7. Third, there are 5 people there. Ones and ones, and then 2. Okay, so I think we're pretty good with those visually. All right. So there's the line plot, but now I'm going to go ahead and ask some questions. So first, how many students are in the class? So they often will give you pictures and you get to answer questions. So how many students are in the class? Okay, well, based on what I've already labeled, we have 4 plus 7 plus 5. What is that? Wow, I'm blinking here. That's 11 plus 5 is 16. Wow. Okay. 16 plus an additional 1, 2, 3, 4. So 20. I'm going to actually write it out though. 4 plus 7 plus 5 plus 1 plus 1 plus 2. Which totals up to 20. 20 students. There we go. All right. That's how we show work. Okay, part B. What percent own more than 3? All right, more than 3 pets, sorry. A percent own more than 3 pets. All right, so the way that's worded, since it says more than 3 pets, 3 wouldn't count. It actually has got to be bigger than 3. So only the 4 and 5 category would work. So we'll take, there's 3 in those 2 categories, and we'll divide it by 20. Let's see. So we're doing a percent. I'm going to do this in my head. I'm basically saying, okay, I'm going to times that by 5, which will give me 100, right? So that'll be 15 over 100 or 15%. Trying to do some mental math there. Okay, so I'll go ahead and make another video for the rest of the numerical data, but that's the categorical and the start of the numerical data.